Hello and welcome to Learn with Indrjeet. This is another video in the series of videos titled Building a To-Do Management System Application in the latest .NET 8 framework from Microsoft. In the previous video, we implemented and tested the to-do list module. If you haven't watched that video, please go ahead and watch that. Also, I suggested you to implement to-dos module following similar steps as we did in the to-do list module. I hope you have implemented to-dos module in your application. In this video, I'll show you my implementation of to-dos module. Also, we'll create a custom exception handling middleware in the web API project. And towards the end of the video, we'll discuss lazy loading. So, let's get started. So here we are in Visual Studio. Let me show you how I implemented the to-dos module. But before that, let me show you a list of steps that are to be followed in order to implement a new module. So first one is the database, where we create the table. Then in the domain project, we create model and interface for our new entity and add an entry in the I unit of work. In the application project, we create the DTO, the view model, and add mappings in the automapper profile.cs. Then we create service interface for the new entity and add its entry in the iData service. Then we implement the service and make an entry and initialization in the data service. In the infrastructure project, we add a DB set for the new entity in the application DB context. In the repositories folder, we implement the repository for the new entity and make an entry in the unit of work. And in the web API project, we create a new controller for the entity. So as of now, we don't have the web app project. We'll discuss these later. Coming back, starting with the database. Here is the table that we have for to-dos. Then in the domain models, here is the model. In the interfaces, here is the iTodos repository with one method, and here is the entry in I unit of work. In the application project, here is the DTO. This one is the view model. Then in the helpers automapper profile, here are the mappings of the models DTO and view model. Then this is the to-do service interface. Here is the entry in iData service. Then the implementation of to-do service and its entry in the data service. See, here it is, and the initialization. Right, in the infrastructure project, DB set in application DB context and the repository implementation as well as its entry in the unit of work. So here it is, and the initialization. Right, and in the web API project, we have the controller for to-dos. So get by ID, create, update, delete, create range, update range, delete range, all functions are implemented. So let's start the application as is and see the Swagger UI. Here it is, and we Here is the to-dos implementation in the UI. Okay. So let's go back, stop the application, close all tabs, and start with the exception handling middleware. So let's first see how an exception looks like. So in the controllers, to-do group controller, let's go to get by ID endpoint and try to throw a new exception from here. So this exception is test exception with an inner exception also, right? So save F5 to start the application in debug mode. Here we are. So in to-do groups, get by ID, let's try to get the to-do group. So here is our response with a 500 status code, and it straight away writes the stack onto the response body. So this is the stack trace. It is showing that this is a test exception. The inner exception is also shown, and it is coming from the to-do groups controller.cs line number 37, right? And all the details are here, right? But we don't want that, because all the API endpoints are supposed to provide a uniform response to the client so that it can be easily consumed. So the structure of our response is data that can be null, status code, title, message, and description. So we have to handle internal servers in such a way that a uniform response is provided to the client. So one way to do that is to wrap all the lines here in a try catch block everywhere in every controller, every service, right? But to do it centrally, let's create a custom exception handling middleware. So in the web API project, let's add a new folder called middlewares. And in this folder, let's add a new class called the exception handling middleware. Okay. Let's make this class a middleware first, then we'll handle the exception. So private read only request delegate, let's name it next, and then let's inject it into the constructor, and then public async task invoke with HTTP context, this one, context, await next context. So a middleware is any class that has a invoke method receiving the context and passing the context to the next middleware in the pipeline, right? Now, while calling the next middleware, if there is an exception, we want to handle that, right? So let's round this line of code with a try catch block. The shortcut is Ctrl KS, and then we select the snippet of try catch. Let's name this exception, and let me replace this line with the code that I have on the clipboard. So we are trying to generate a uniform response for the client here. So we are setting the response status code to internal server 500, the content type to application/JSON. We are capturing the source of the exception. Then we need this environment. So let's put it here. So I web host environment should be there, called the env, right? So if the environment is development, we are capturing the inner exception. If it is not null, then the stack trace, replacing all the empty lines, all the line endings with environment.new line. Then later on we'll create a HTML body to be sent into the email in development or in production. Then we are preparing the response using the API response builder, generate internal server error method, right? And then we are writing this response, writing it to the response. In the production or staging environment, we are not providing any information of the stack trace. We are only providing the exception message to the response, right? So this is the exception handling middleware. And how to use this? We should go to the program.cs and application build, redirect, and down here app.use middleware, and we specify the name, right? And that's it. So let's now hit the API endpoint, which throws the exception, and see the result. So F5, here we are, get by ID, and let's execute it now. So now the response that came in is just as we needed. Now it is our custom response. It is showing the data as null, status code as 500, internal server error is the title, web API is the source of the exception, and this is the main exception, right? Along with the stack trace that was there in the description. So this is the uniform response that is coming from all the API endpoints, and it is now consumable to the client, right? Coming back, let me show you how to create the HTML body to be sent into the email if required. Let's stop the application. In order to create HTML body, let's create a class called message builder inside of this helpers folder. So message builder, we are creating this class in the application project so that we can use it later. So it will be a static class with this function to generate an HTML body out of the context as well as the exception. So let me paste that here. So this class will have one function called build exception message, receiving the context and the exception. So the message builder, the string builder, we are appending first line as a h1, which shows the message. Then if the user identity is authenticated, means the user is logged in, Then we are also showing the username, then the request path, query string parameters if there are any, and then the stack trace. If stack trace is not null, then we are showing the stack trace, inner exception, and then any form data if there is the form data, and then we are returning a string, right? So we will use this build exception message to create this HTML body. So let's replace this code with message builder dot the function name, and it is asking for the context and the exception. So context is already present here as well as the exception, right? And now we can send this HTML body into the data of our response, or it can be sent to the email in production environments to the technical team so that they can see the HTML page containing the stack trace and all the details, right? So there are a lot of play arounds related to this. So for the time being, let's leave it as is, and we are not even using the inner exception to show to the user, and even in development environment we can do that. But I hope you understood the concept of exception handling, right? Now let's talk about lazy loading a bit. Let me close all these tabs and let's go to the web API to-do list controller, where we are fetching a list, and a list may or may not belong to a group. So we'll take an example of a list which belongs to a group, right? So let's go to the service get method and put a breakpoint on line number 35 so that we can see the model. What I'm trying to show you is a to-do list has a parent, right? That is a to-do group, and we want the to-do group to come along with the list. Let me show you that. So F5, let's go to to-do list and get a list. As we know, to-do list with ID number 1 has a parent to-do group. So let's continue from here, and here is the model. So see, the to-do group is null, right? So we cannot have the to-do group name. So to get the to-do group, get the related data like the parent or the child, we need to implement lazy loading, and for that we need to go to use SQL Server. So these are the DB context options, and right here we need to specify lazy loading, use lazy loading proxies, and we need to set it to true so that related data is loaded while fetching any data from the database. So the second change is in the to-do list model, this one, we need to make this parent property as virtual. Right now, let me show you the effect of these two changes that we done in the application. So let's try that again and execute. And now when it hits, the model now contains the to-do group also, and out of this parent we can extract the group name, right? So earlier when we were not using lazy loading, this property was null, and lazy loader was not there. So lazy loading is all about fetching related data. It might be parent or child data. And in order to use lazy loading, first of all, we need a package that is already installed. That is the Microsoft Entity Framework Core Proxies. Then we need to configure the application DB context options to use lazy loading proxies, and in the model the related data should be made virtual. Okay, so this is all about lazy loading. If you want to explore on lazy loading, please visit the Microsoft site. I hope you like the content of this video. If that is so, please like, share and subscribe to my channel, and in comments let me know what you are learning from these videos. If you have any queries or questions, please ask them in comments. Thank you for your time. Keep learning.